So good morning students, welcome back. Today we'll discuss lens-maker formula. It gives a relation between object distance u, image distance v, refractive index mu and radius to curvature of the lens. So let's start topic lens-maker formula. Look at students, we are given a double convex lens. Biconvex lens L, this portion is L1 and that portion behave like a L2. Okay, that is a double convex lens. Okay. O is the object. We know every object emits the light rays. So it emits the light rays. After getting reflection, it forms its first image I1. Lens to object U, lens to first image V1. Look at this. I1 is the image for L1, but I1 is placed in front of the portion L2. So for this L2 portion, from this rear portion, it behaves like object. Again, the light rays emits, and this L2 will form its final image I, and the lens to final image distance is what? V. Look at R1 is the radius of curvature of this portion L1, this portion, and R2 is the radius of curvature of this portion L2. Okay students. Now students, refraction is taking place. First of all, we'll write from rare to denser for the portion L1. We know what is the equation for refraction rare to denser. Mu2 by V minus mu1 by U, mu2 minus mu1 by R, where mu1, mu2 are the refractive index, mu1 is the refractive index of rare medium and mu2 is the refractive index of denser medium. V and U are the object, U and V are the object in image distance respectively. R is the radius to curvature. So for lens L1, object distance is U, so U remains U, and for lens L1, first image distance is V1, so V replaced by V1. Understood? Object distance is U and image distance is what? V1. So U remain U, object distance is U and image distance is V1. So V replaced by V1 and radius curvature R1. Okay, first equation. Now since finally the rays comes from denser to rare. So write the portion L2 from denser to rare. What will the equation actually? Mu1 by V minus mu2 by U equals to mu2 minus mu1 upon minus R. That is the equation for refraction denser to rare. So here for lens L2, for final image I, this behave like an object and that behave like an image. So U replaced by V1 and V replaced by V1, nothing will change, and radius curvature is what? R2. Now since this is refraction rare to denser, this is refraction denser to rare for L1 and for L2, now adding both the equation. So when we add both the equation, look at this. Which part? This plus mu2 by V1 cancel by minus mu2 by V1. And look at mu1 by V minus mu1 by U. That part will come. And mu2 minus mu1 will common. Okay. 1 upon R1 minus 1 upon R2 will remain. Is it clear? Now finally what is common? Mu1. 1 upon V minus 1 upon U. Mu2 minus mu1, 1 upon R1 minus 1 upon R2. 1 upon V minus 1 upon U, that is the lens formula. 1 upon F. 1 upon V minus 1 upon U equals to 1 upon F. This is called a lens formula. So that is become 1 upon F, mu1 divided both, mu2 by mu1, and mu1 divided by mu1 will get 1. And mu2 by mu1, that is relative refractive index mu. So 1 upon F equals to mu minus 1, 1 upon R1 minus 1 upon R2. This is the lens maker formula. This equation is representing the lens maker formula. 1 upon F equals to mu minus 1, 1 upon R1 minus 1 upon R2. F is the focal length, mu is refractive index of material, while R1 and R2 are the radius of curvature of this portion L1 and L2. Okay students?